Hello Huskies! Today we are going to practice solving some harder equations. Sorry about the noise there. We're going to do multi-step equations, including those using fractions and decimals. I'm going to work out all the problems on the classwork and then 4 of the homework problems. And so if you feel like you just need help on the homework, you're welcome to skip to the end. If you're still confused about what's going on the homework, then you should probably watch this entire video. Obviously, our objective today is that I can solve multi-step equations. Okay, so I started right off with this diagram. Maybe you remember from 7th or 8th grade where you talked about vertical angles. Vertical angles are formed when two lines intersect. And they kind of look like you can mark them with this little bow tie thing. So this angle right here, this measurement, is going to be the same as this one. Vertical angles are congruent. That is something that's true in geometry all the time. If they are formed by two straight lines, then vertical angles are congruent. Hopefully you remember what congruent means. That's that little equal sign with the worm on it. That means they're equal. Their measures are equal. Okay, how could we figure out how big those angles are? I mean, we have some algebraic expressions, but I want to know, like, in degrees. How big is that angle? So, I know they're equal. That means that I could probably make these two expressions equal to each other. 3x plus, that's a plus, 45 would be equal to 6x plus 18 then. Because they are equal, then I have just set up an equation that will help me figure out what x is. And once I find x, I can use it to find the measure of these angles. Okay, but now what do we do? Well, here we have one of those equations. This is kind of like if you can get any equation to this point, you'll be able to solve it. So use this kind of like your baseline or your landmark. Just know for sure that you can solve an equation that has a variable on each side and a constant on each side. If you understand how to get from there to the end, then all you have to do is simplify really difficult equations to this point, and then you're home free. Does that make sense? So we want to make sure you understand very well how to solve an equation when there's a variable on each side and a constant on each side. Okay, well, the first thing that you need to do is simplify until you get to this point. Obviously, we're there. And then we talked about this last time on the steps, the rules you're allowed to do, that you need to get all your variables onto one side. And you can do that you can move them all to the left or all to the right. It's your choice. You will get the right answer, whichever side you choose. It doesn't matter. It's just one of those preference things. Okay, so I'm going to choose then, I'm going to move all of my variables to the right-hand side, just for a couple of reasons. One reason is I can kind of peek ahead and see that if I moved everything to the left, I'd end up with negatives, and I sort of try to avoid negatives. Another reason is that usually kids move everything to the left, and I just want to show that you can do it the other way. You don't have to move everything to the left out of habit. Okay, how do I move this 3x to the right-hand side? Well, I'm going to choose to subtract it from each side, not because of this plus sign, not at all, but because there's an invisible positive sign in front of that. That is a positive 3x over there. And how do I undo that? It's by subtracting. That's the opposite operation. So that's why I'm going to subtract 3x from both sides. And when I do that here, I get nothing left. Yay! And on the right-hand side, I get 3x. Some people like to draw this line to help them remember where the equal sign goes. That's totally fine. And so over here I still have 45, and on the right hand side I have 18. Now I'm trying to get x by itself. That's my goal. So x was multiplied by 3, and then I added 18 to it, and I got 45. So to undo that, I'm going to first do the last thing. I got to undo the last thing that happened. So I need to subtract 18. And 45 minus 18 is 27. And that's just going to equal 3x because over here I got 0, and 0 plus 3x is 0, is 3x, I mean. Okay, so 27 equals 3 times some number. To get that number by itself, I'm going to divide both sides by 3, and I got that x equals 9. Hey, I'm feeling pretty good about that. That doesn't answer the question, though. The question was not find out what x is. The question was, well, how big are these angles? X equals 9 does not answer that question. But since I know that this angle is represented by this expression, I could now replace x with what it equals. I know x was 9. And so this angle must be 3 times 9 plus 45. And that is 72. So this is a 72-degree angle. And since they're vertical angles, this must also be a 72-degree angle. Let's check just for sure. Just for kicks and giggles, just for fun, I would plug in a 9 instead of x. And then I would add 18. Hey, 6 times 9 is 54. And 54 plus 18 is 72. Now, if you took a protractor and you measured this angle, it's not going to measure 72 degrees. I can tell you that right now. But that's okay, because I'm not asking you to find it using a protractor. I'm asking you to find it using algebra. And in geometry, you cannot just assume that a drawing is to scale. In fact, this is definitely not to scale, because I just found out that those angles measure 72 degrees. But what about the protractor? Doesn't matter. The algebra tells me that's what they measure, and that's what they are. So, when you're solving these problems with the angles, you have to remember a little bit of geometry. I know, gasp. You have to remember stuff from 8th grade. Pretty much everything from 8th grade. You guys have got to focus on learning, because the stuff that you learn every year in math, it builds on that. And there's not always going to be a lot of review. The new core, which you guys have actually had for quite a few years now, it assumes you just remember everything you've been taught. There's not a lot of overlap. So yeah, if you were taught about vertical angles last year, and you definitely were when you had the unit on the parallel lines cut by a transversal, do you remember that? You talked about vertical angles. You also talked about alternate interior angles. You remember that? Those are also congruent. And you talked about alternate exterior angles. Those are congruent. And you talked about corresponding angles, which would be like this one and this one. And you talked about supplementary angles and complementary angles. Yep, you need to remember all those. So I might give you some hints on the homework or the classwork about what those vocabulary words are, but not on the test. And this is something you definitely need to know going forward. Okay, so numbers 2 and 3, we're just trying to make sure you can solve these equations. If you were absent on this day and you don't understand how to do this, then you should probably just watch me solve them. But if you were there and you're just not quite sure, you're just kind of fuzzy and you're watching this video just to strengthen your skills, then I want you to pause the video and try to do these two problems on your own, and then turn it on and see if you did it right. Okay? If you weren't there today, you're welcome just to watch me go through. Okay, so here we have on number 2, one of those landmark equations that I was talking about. We have variables on each side, and we have constants on each side. So this is the thing that you should know. Once you get to this point, you should be like home free. Okay, I know how to solve these, yay. So I'm going to solve this one. I'm going to solve this one because it sort of looks the same as the other one, but I'm going to do it the opposite way. I'm going to subtract 6x this time so I can move all the variables to the left. Aha, last time I moved them to the right. I'm not afraid of negatives. I can do that. So 3x minus 6x is negative 3x. And then the plus 5 is still there. Those added up to 0. Let me move this over a little bit. I'll tell you, I have quite a few pet peeves when it comes to solving equations. And one of them is when kids just do that, and then they call it cancel. I don't like that, because there's going to come a time when there's nothing left on that side of the equation. And if you just draw a line through it, then you will sit there staring at it and be like, I have no idea what to do next. I know. Don't just draw a line through it. Remember what it means. You added 6x to negative 6x, and that adds up to 0. And I put the little smiley face inside the 0 because we wanted that to be 0. That's good news. But 0 plus 8, that 8 is still there. And then here's our equal sign that hasn't moved. Okay, so again, it's really important that you understand that process. When you add those up, they don't just magically disappear into the ether. They add up to be 0. They're additive inverses. And when you add them together, they get 0. Okay, so now what do we have? I'm just going to rewrite this because I'm a little OCD when it comes to solving. So negative 3x plus 5 equals 8. I'm trying to get x by itself. I have multiplied it by negative 3, then I added 5, and I got 8 for a result. So if I'm trying to undo all those steps to get back to just plain x, the last thing I did was add 5, so the first thing I'm going to do is subtract 5. I have to undo that operation. And I have negative 3x equals 3. Because guess what? Don't just do that. No, that adds up to be 0. And yay for 0. Okay, 3x plus 0 is negative 3x, I mean. Negative 3x equals 3. Divide both sides by negative 3. Here's another reason why I don't just like drawing the line through and calling it cancel. Because right here, when you add these up, they add up to be 0. And kids will call that cancel. But right here, what's going on? People will draw a line through those also and call that cancel as well. But guess what? Negative 3 divided by negative 3 is not 0, it's 1. And so that's why I hate the word cancel, because sometimes people use it to mean adding, and sometimes people use it to mean division. Sometimes people use it to mean square rooting. Like, it could mean anything, and that's why it's confusing. So I will almost never use the word cancel. I hate it. And I don't like to just draw the line through there. I like to show what's happening. Negative 3 divided by negative 3 is 1. That's where the 1 came from. And then on the right-hand side, we have 3 divided by negative 3, which is negative 1. 1 times x is x. That's the multiplicative identity property. And so x is just negative 1. Yay! Okay. I always say I want to do these faster because I feel like I talk so much, so I'm sorry. But, that's why you're watching this, right? So you can get an explanation. Okay, number 3. I see parentheses. You probably do too. We need to distribute this negative 5. Don't forget the sign in front needs to go with it. The negative 5 needs to be distributed. Well, then what do we do with that 4x? You can't combine the 4x with the negative 5 because, first of all, they're not like terms, but more importantly, you can't add or subtract before you multiply. And what we have going on here, whoops, I meant to say erase. What we have going on here is order of operations says we should multiply first. And this negative 5 being smushed right up against these parentheses tell us we have to distribute that negative 5. Distributing is multiplication. So in other words, the 4x does nothing, just sits there. And now I'm going to distribute that negative 5. Negative 5 times 2x is negative 10x. And negative 5 times negative 3, watch your signs, negative 5 times negative 3 is positive 15. And then the 2x minus 5 on the right-hand side of the equal sign hasn't changed, so I just recopied that. Okay, so remember your rules. You've got to simplify on one side. We're going to just, here's our equal sign. We'll simplify on the left, then we'll simplify on the right, and then we will get to our landmark situation where we have, a variable on each side and a constant on each side. So the first thing I can see here is on the left now, I have 4x and negative 10x. I don't need to do this to both sides. I am just focusing on the left-hand side of this equation. Here's my equal sign. And on just the left-hand side, I have 4x minus 10x. Well, 4x minus 10x is negative 6x. There's nothing to do to both sides. Hey. I am just simplifying this on the left only. Then I'm just recopying all this other stuff that hasn't changed. Hey, we're at the landmark state where it's a variable on each side and a constant on each side. So now what do? You should move all your variables to one side, all your constants to the other side, and then divide. That's the steps when you get it to this point. So I'm going to go ahead and add 6x to both sides. Again, Doesn't matter if you wanted to move the 2x to the left, you totally could have. You would have ended up with a negative 8x, and that would just show that you're brave and you're not afraid of negatives either. So negative 6x plus 6x is 0. Good. Add it up to be nothing. That's what I wanted. I still have a 15 here. 2x plus 6x is 8x. And the negative 5 hasn't done anything. I'm just dragging it along. Okay, now that I have all my variables combined and on one side, I've got to move my constants over to the other side. Remember, the constant is the number without the letter attached to it, just the plain old number. So since I was subtracting 5, the opposite of that would be adding 5, and that will get me 20 equals 8x. Okay, now I've got a number equals a coefficient and a variable, so I'm going to divide both sides by 8 to get rid of that coefficient. 20 divided by 8 happens to be 2.5. 8 divided by 8 is 1, which is, 1x or just x. We don't even need the 1. If you want to write the 1, I'm never ever going to mark that wrong. It's totally fine. Mathematicians tend to be lazy, or efficient would be the nicer way to put it, and so we don't write stuff that's unnecessary. And 1 times x is x, so I don't ever write the 1. It's invisible. If you want to write it because you want to remember what happened to the 8s, great. That's awesome. One more comment about this. If you wanted to leave this as 28ths, that's okay with me. Don't even need a calculator. Maybe it would have been better to simplify. You could have turned that into 5 halves by reducing your fraction. But 2.5 is okay, 28ths is okay, 5 halves is okay. This lesson is not on how to simplify fractions. It's on, can you solve this brutal equation? Hey, we did. Awesome. Okay. I want to talk for a minute about fractions. So that's why I've made this cute little problem here. I'm going to show you 3 different ways to solve this problem. Actually, maybe 4 or 5 different ways. You don't have to do it all those ways. You pick the one that makes the most sense to you and do it that way. You might have a different way to do it, and that's okay too, as long as it's not just using the calculator and rounding off, because boy, I hate that. So, all right, so if we are on this road trip and I want the children to stop asking me when we're going to be there, which is actually what my dad used to do to me in the car, he would give me math to do, then I would say, well, we have driven 160 miles and we're 2/5 of the way there. So if you want to know how long the trip is, you got to figure it out. Well, I'm going to draw a little picture. This might help some people kind of see what's going on here. If I say this is my entire trip, okay, that's how far it is from my house to Denver, then I split it into fifths, like that. Each one of those little sections is 1/5 of the trip to Denver, and what do we know? We know that we have gone 2/5 of the way. And how far is 2/5? Well, it's 160. That makes sense, right? 2/5 of the way, which is 160 miles. So now just by looking at that picture, I bet you could figure out how far the whole trip is. There's several ways to do that. One way is to notice, well then this must also be 2/5. So that's another 160. But what's this? This far is 1/5. So how far is just 1/5? Well, it must be half of 160, or 80. Now I want to show you what that looks like in an equation. So I'm saying 2/5 of my entire trip is 400. Oh, just kidding, as I give you the answer. Is 160. Okay, 2/5 of the whole trip is 160. And so instead of trying to solve that maybe the way that you've been taught with reciprocals or something like that, I just want you to think about this. Okay, if 2/5 of the trip is 160, then how much is 1/5 of the trip? Two of them is 160, so 1/5 of the trip, we already learned that, must be 80. Does that make sense? That one part of it would be 80. Okay then, if 1/5 of the trip is 80 miles, then how far is 5/5 of the trip? what am I doing here? Well, I've taken it kind of down to a unit rate. I'm saying that one of these parts is 80, so this must be 80, 80, 80, 80. 1, 2, 3, 4, 5, it must be 80 times 5, which is 400. And so I've kind of divided this, the 2/5 up in half to be a 1/5, and so I had to divide the 160 by 2 to get the 80. And then so I made it smaller, and then I made it bigger by multiplying by 5, because what am I really interested in here is how big is the whole trip, which is x. And 5 divided by 5 is 1, or 1x, and you know, we just talked about, how you don't even need the 1, so x must be 400. So that's an alternate way to solve this. You could draw a picture every time if you want. Can't always draw a picture that's that simple for fraction ones. But I'm going to show you another method. Maybe you like it better. So if I have 2/5 x equals 160, what I want to remind you is that this fraction actually represents two different operations that's happening to the x right here. I am multiplying the 2 times the x, then I'm dividing by 5. The 2 is being multiplied by the x, and then the 5 is being divided into that. And so I actually could solve this in 2 steps by just undoing one step at a time. So let's undo the division by multiplying. So I would multiply both sides times 5. So I'm going to multiply that. Sorry, that little arrow will go away. Multiply both sides by 5. Well, 5 divided by 5, that multiplicative inverse thing is going to be 1. And so I just have that 2x equals 800. Then how do I get rid of the 2? I got to divide both sides by 2. So x equals 400. So see, that was another way to solve it by treating it as a two-step problem. First, you could multiply by both sides by 5, and then you could divide both sides by 2. Okay, I am going to show you one more way to solve this problem. Yeah, I have one more way. Okay, so we'll go back to our original equation that we were trying to solve. 2/5 of something equals 160. And maybe this is the way that you were taught how to do it, which is totally fine. I'm not saying it's wrong. Great if this makes sense to you. But sometimes people forget what to do. So I'm just trying to show you alternate methods. So whenever you have a fraction like this being multiplied by a variable, you can just multiply both sides by the reciprocal. And the reciprocal of that fraction is 5/2. And so you could just type it right into a calculator, 160 times 5/2. Well, what's happening over on this left-hand side is that multiplicative inverse thing where 5/2 times 2/5 just becomes 1. So I got 1x, and then when you type in 160 times 5/2, it becomes 400. Just to point out, well, 160 times 5, that sounds like what we did over here, right? 160 times 5, and then we divided by 2. 160 times 5/2 is doing this method just in one step instead of 2. So that's kind of like why the reciprocal thing works. So that's an alternate method. Just go straight to the reciprocal. Okay, I hope that helps a little bit with what some of the anxiety of when a fraction is in an equation. Pretty much there's going to be a lot of fractions in equations today, so we got to get over that. Okay, here are 3 more. So I'm going to do these in kind of all those different methods just to review. The first way I'm going to do A is to multiply both sides by the reciprocal. So I'm just going to write it out where I get a little bit more room. 9/2 x equals 27. Move that over. Okay, so then I have a fraction being multiplied by my variable. To get my variable by itself, I'm going to multiply by the reciprocal, which is just when you flip the fraction. That's what reciprocal means. Okay, so 2/9 times 9/2, reciprocals always multiply together to be 1. That's what that means. And 2/9 times 27, I'm okay if you just type that in the calculator. If you're not so great with fractions, fine, just type in the calculator and you will come out with 6. there is a better way to type that, to figure it out without typing it in the calculator. 2/9 times 27, but guess what? I'm not going to talk about that right now. I'm going to wait until we do number 6. Okay, so let's go look at B and do B a different way. So let's do this one in 2 steps. It starts with 3/7 times x equals 15. Let's just start by getting rid of the fraction. Let's undo the division of 7 by multiplying both sides by 7. 7 times 1/7 is just going to give me 3x, and 15 times 7 is 105. Well, then you're going to solve this by dividing both sides by 3, and x equals 35. Okay, so again, you can see that these problems are not exactly the same. We're getting different answers, but you can see that they're sort of set up the same. A fraction times a variable equals a constant, and you can choose whichever way you like. Now, I'll tell you how lots of you do these problems, and that's how I'm going to do this next one, C, but I'm going to show you the pitfall. So a lot of you are just like, I don't know, but I have a calculator to help me, so I'm just going to do it on the calculator. And you're saying, well, I have something times x equals a number, so I'm going to just divide both sides by 5/6. That's not a wrong idea. Yeah, you're multiplying by 5/6, so to undo multiplication, you divide by 5/6. But the problem is, your calculator can't read your mind. And what you're trying to type in there is 4 divided by 5/6. But on the calculator, if you type 4 divided by 5 divided by 6, it's going to probably give you the wrong answer. Especially if it's a crapulator, which means it doesn't understand order of operations very well. What you have to do is tell the calculator, you know what, this is a fraction. This whole 5/6 thing is a fraction. If your calculator does fractions and you say 4 divided by 5 and it does like a little fraction symbol thing, 5/6, then that'll work. That's totally fine. But the calculators we use in school, they don't have a fraction button. You just have to use divide, and I'm telling you, you have to keep that 5/6 in parentheses to make that work. So whatever calculator you're using, whatever method you're using here, you should get out for an answer on this one 4.8. If you don't get 4.8, your calculator is misinterpreting what you're typing. So just double, triple check that you're typing it in the way that you want to. If you use your fraction button and it spits out 24/5, well, good news, that is 4.8. Okay, I don't like C, the method that I did on C, I don't like that the best. Personally, I use the reciprocal method like I showed you on A, but sometimes if it's complicated, I do this 2-step thing like on B. Pick your method, do it your way, I don't care. Okay, so number 6, we are just trying to multiply 12 by 2/3. There's a reason for that, and it's going to be what we have to do on the back side of this classwork. I'm kind of giving you a warm-up problem. So if I'm multiplying 12 by 2/3, then I'm just trying to see if you remember that when you multiply fractions, they both need to be fractions, like that. So you're going to put the 12 over 1, and multiplying, you go straight across. 12 times 2 is 24, and 1 times 3 is 3. And 24 divided by 3 is 8, so I can simplify that even farther. But wait. What if I noticed way back at the beginning that there was a common factor here in the 12 and the 3, and I divided 3 by 3 to give me a 1 here, and I divided 12 by the 3, that would give me a 4. Well, 4 times 2 is 8, and 1 times 1 is 1, so you can simplify first if you want. Okay, so what I just did completely relates to what we were doing back here on 5A when you had to multiply 27 by the reciprocal of 9/2 by 2/9. So if you didn't want to type it into the calculator and you wanted to do it by hand, which is actually faster, put your 27 over 1 and notice that 9 can go into 9 one time and 9 can go into 27 3 times. 2 times 3 is 6, 1 times 1 is 1, booyah, it's 6. I can do that faster than you can type it in your calculator, and you can too if you keep trying. Okay, so B is just another one. It's actually the same thing. Multiplying 12 by 2/3 and finding 12 times 3/4. It's the same process. I just wrote it two different ways. I know the fractions are different. You're going to get different answers. Make sure, no matter how you do 6b, that you get 9 for an answer. If you don't get 9, you're going to have to go back and try it one of the ways that I've already shown you. Okay, those little prerequisite skills are going to help us solve some pretty complicated equations. I hope you're really proud of yourself. When we're done with these, you can see that you can tackle something pretty complicated and do it just by taking small bites. So when equations have fractions, lots of us don't like fractions. So I'm trying to teach you how to make it easier. And one way that a lot of kids try to make it easier is by turning all the fractions into decimals. Well, the problem with that is that I don't know many ninth graders who are very good at rounding. And most of them round wrong or round off too soon, and it changes the answer, and then you get it wrong. So, you know what? Rounding off and turning them into decimals and rounding off is not easier. It's just going to lead you down the wrong path. I'm just going to teach you how to get rid of the fractions completely. So that's what we're going to do. We're going to turn all those coefficients that are fractions into whole numbers. No fractions. Sound good? Okay, here's our question. What can you multiply 2/5 and 1/3 by to make them whole numbers? In other words, we just need to get rid of the fraction. We don't have a problem with what's in the numerator. Hey, these aren't hurting anybody. 2 and the 1, yeah, I don't got a problem with that. I have a problem with the 5 and the 3 in the denominator. We're going to find a number to multiply by both of these fractions to get rid of that. Well, the number is 15, if you didn't see it already, which is 5 times 3. It's a product of those denominators. So let's go back and just solve this little, it's a kind of a medium difficulty equation. We're going to solve it by getting rid of those fractions. And I'm going to multiply the entire equation by 15. But I'm not going to write it as 15. I'm trying to space this out because I write so big I need more room. I'm not going to write it as 15. I'm just going to write it as 5 times 3. 5 times 3 is 15, right? So I'm going to multiply this fraction by 5 times 3, and this fraction by 5 times 3, and this fraction by 5 times 3. I could have written 15, but I'm going to show you right now why I chose to just keep it multiplied out like that in the factors. Because remember how we were doing this whole simplifying process right here? Some people call it cross-canceling. We're going to do that now. Let's simplify. Well, hey, look, 5 divided by 5 is 1. 3 divided by 3 is 1. 5 divided by 5 is 1. Wow, what a coincidence. All of those numbers divided away. Not a coincidence. We set it up that way on purpose by choosing this number based on what was in the denominator. See how we had a 5, a 3, and a 5? Oh, well, 5 times 3 would take care of it. So what we actually have left now is 3 times 2 times x minus 5 times 1 equals 3 times 3. All those denominators became 1. They're not there anymore. We have turned all those fractions into whole numbers. Yay! Now, this still might look kind of complicated, but if I simplify it a bit more, 3 times 2 is 6. 6x minus 5 equals 9. Can you solve that? Yeah! That's no problem at all. 6x minus 5 equals 9. Add 5 to both sides. We got this 6x equals 14. So x must be 14/6. I'm okay with that. Or 7/3. Or you could type that on a calculator if you want, but you know what? I don't want to. I like this. This is my answer. 7/3. Boom. Done. Don't turn it into a mixed number. I hate those. 7/3. It's great. Perfect. You're done. I didn't even need a calculator to do that. Nowhere in that problem. Wow. Okay, so let's just think through a couple of steps here. Number 8. To make this equation easier to solve, we would want to get rid of all the fractions. So what would we multiply by so that we could turn all those fractions into whole numbers? You look at the denominators. I've got a 3, a 7, A 7, what's the denominator of the 2? 1. So I don't really need a 1. So I'm going to multiply this whole thing by 3 times 7. So you look at the denominators, and you don't have to use 2 of them. If there are 2 7s down there, you just have to multiply by a 1 7 denominator. And I don't work out an example like this on the classwork, but I do just want to point out right here that you have to multiply each term by the number. So we're going to multiply each term by 3 times 7. This one, this one, this one, and even the 2. You'd have to multiply by 3 times 7. So you might be saying, why? That's not a fraction. I don't need to do that. I know it's not a fraction, but you have to multiply every term by the number in order to keep this equation balanced. Whatever you do on the left, you have to do on the right. You know, multiply both sides by 21 is actually what we're doing here. So you can't leave that 2 out. And that's going to be the most common mistake people make, is they forget the numbers that aren't fractions. Okay, we're not going to actually solve it because it says don't. We're just going to go on to this one, number 9. Okay, here we go. It's kind of complicated, looks kind of scary, but remember, it's not that bad. In fact, once you get rid of the fractions, it's sweet. It's easy. So we're going to find the lowest common denominator, and we're going to keep it in factored form. So let's look at the denominators. We have a 3, a 2, a 4, and a 3. You know what, if you just don't even want to come up with the lowest common denominator, you just want to find a common denominator, that's fine. You could multiply every single number by 3 times 2 times 4 times 3. I'm not going to stop you. That's fine. But we could make that smaller. We don't need to do 2 3s. No, 1's good enough. So you could just multiply everything by 3 times 2 times 4 if you want to. Let's just do that. And some of you are going to see that there's a smaller number you could use. That's great. I'm not even going to go there. I'm just going to 3 times 2 times 4. I'm just going to use that. Kind of like a robot. If you can see a smaller number, I'm not going to stop you. Definitely do it that way. So let me just, recopy this bigger because I need more space. 3/4 x minus 2/3. I'm going to multiply everything by 3 times 2 times 4. So I'm just going to write it next to everything. 3 times 2 times 4. Why am I not multiplying this out? Why am I saying 3 times 2 times 4 instead of 24? Well, because remember, I got to just divide by all these denominators anyway. So I might as well keep it out in factored form so it'll be easier. I'll just be like, boom, the 3's divide away. The 2's divide away, the 4's divide away, and this one's another 3. All those denominators just became 1. I am out of the fraction business. Done. What do we have left? We have 2 times 4 times 2 times x. See this 2 that was still there? 2 times 4 times 2 times x. That's what's left. Minus 3 times 4 times 1. Equals 3 times 2 times 3 times x minus 2 times 4 times 2. You don't have to do this step if you can just simplify it straight away, but another common mistake that people make is like forgetting stuff, forgetting that there was this negative here. That's tricky. Forgetting this negative, forgetting that there was still a 2 left here. So I like to write everything out like this. Now let's start to simplify. 2 times 4 is 8 times 2 is 16. 3 times 4 times 1 is 12. 3 times 2 times 3 is 18. And we have another 16. Hey, look at that! It's our landmark equation. We have a variable on each side and we have a constant on each side. So you should know really well what to do from here on out. So I'm gonna move everything to the right this time. I got 0. Yay for 0! 2x minus 16. Let's move the 16 over by adding it. I get a 4 equals 2x. And then I'm going to divide both sides by 2. And hey, x equals 2. Done. So we turned that super complicated looking nasty equation with 4 fractions, it eventually boiled down to this super simple equation right here. Look at that. It's our landmark equation, your friend, the thing that you should know how to solve really well by now. Variable and a number, done. Okay, here's 2 more to practice. Actually, 4 more to practice, right? So I'm going to just go through these really quickly because I'm more interested in the answers than the process. I hope you've seen enough process by now that you're good at them. If you have questions about some of the homework problems, these might help you understand why the answer is what it is. So I'm just going to kind of quickly go through. So distribute 2x minus 8 plus 6, 2x minus 2. Combining all the like terms, I get 2x. Wait a minute. 2x minus 2 equals 2x minus 2. What if I subtract 2x from each side? What's going on here? Negative 2 equals negative 2. All my x's added up to 0. Does negative 2 equal negative 2? Yep, it's true. It's always true. There's no more x, but the thing that is left makes sense all the time. That means that your answer is all real numbers. Do not write an infinity symbol. That just means that there are an infinite number of solutions, but what are they? They're all the real numbers, all the numbers you could think of. Okay, number 11. You have some like terms to combine on each side. So 9x minus 6x is just 3x. And 3x minus 5 plus 6 is plus 1. So again, I didn't move anything from one side to the other. I just simplified on the left and I simplified on the right. Now I want to try to maybe move the 3x over, but oh no. What's going on? 1 equals 2? 1 does not equal 2. That is not true. And it's never going to be true. That is false all the time. 1 does not ever equal 2. So that means that it's no solution. There is no possible way this will ever be true. No solution. Okay, so I wanted those right next to each other so you could see the difference. We got out something that was always true. That's all real numbers. We got something that's never true. Then there's no solution. There's no number that works. Okay, let's look at a couple more here. Combining like terms and simplifying gives me 5 minus 6x equals 5 minus 3x. Yeah, I skipped a couple steps. If I subtract 5 from each side, I end up with negative 6x equals negative 3x. Now, here's a perfect example of why you don't just draw the line through and call it canceled. Because if I was trying to move all my x's to the same side, and I'm going to add 3x to both sides, don't just draw the line through it and cancel it, because you'll be lost. Negative 3x plus 3x is 0. And negative 6x plus 3x is negative 3x. Negative 3x equals 0. What? What does that mean? Does that mean it's no solution? No. No, 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 no. If you ask a second grader this question, they will tell you the right answer. Don't make it more complicated than it is. I'm thinking of a number. I multiplied negative 3 by the number and I got 0. What's my number? Every 8-year-old on the planet will yell, 0! They know that. So, in other words, negative 3 times 0 is 0. It must be 0. If you really want to go through all the steps and divide both sides by negative 3, that's fine. 0 divided by negative 3 is 0. X equals a 0. That is a solution, my friends. That works. It's a number. 0 is a number. You can totally have that for an answer. There's nothing wrong with it. So the danger on questions like number 12 is that kids stop too early and they just go, what? This doesn't make any sense. They stop right here and think that it means no solution. No. No. Negative 6 times some number is the same as negative 3 times that number. Well, the only number that is ever going to work there is 0. 0 is a number. People, you hurt 0's feelings all the time by telling it that it can't be a solution. Okay, so let's look at 13 And wow, we have some big fractions. What are the rules though? What did we do before when we had fractions? We found the denominators, right? We looked at the denominators. We came up with the lowest common denominator. We multiplied everything, both sides of the equation, by that denominator. Okay, let's do that. So we have here a 5 and we have a 3. Guess what I'm going to multiply by both sides by? 5 times 3 and 5 times 3. Now, be careful, because this is the first time you've seen this, but we have an expression in our numerator instead of just a number. So we have 5 times 3 multiplied by 2x minus 4 over 5. And on this side we have 5 times 3 multiplied, whoops, I don't want that yet, by this fraction, 4 minus 2x, all divided by 3. Now the fraction bar kind of acts like parentheses. I know it's sort of invisible, but you have to kind of think of it as being in parentheses like this. Those things are grouped together because of order of operations. We have to divide all those things first. But also notice that we can divide 5 divided by 5, or 5 times 1/5. That's that multiplicative inverse thing. And over here the 3's will divide away. So really, what do we have? We don't have fractions. We don't have no stinking fractions. We have 3 times 2x minus 4 equals 5 times 4 minus 2x. Oh, happy day! I got rid of all my fractions. Now I have to do some distributing, but this isn't a very complicated equation. 3 times 2x and 3 times negative 4 equals, okay, distribute the 5, and you're going to get 20 minus 10x. Oh, looky there. What have we got? We have our landmark equation that has a variable and a constant, and a variable and a constant. Okay, you should know the steps to solve that then. Remember, there's your equal sign. Let's add 10x to both sides. Add that, and we're going to get 16x minus 12, equal sign is still there, 20, and those added up to be 0. Yay! Okay, add 12 to both sides. This part should be simple. It should start feeling like your second nature, like you don't have to concentrate as hard on it anymore. It's starting to be natural to you. Okay, divide both sides by 16, and x is 2. Wow. Okay. How do you know if a problem has no solution, infinite solutions, or the variable has a value of 0? Those are the 4 questions that we just did. We had one solution. That was number 13. The solution was 2. On number 12, it also had one solution, a solution of 0. And then we had one that was all the real numbers and one that was none of the real numbers. So no solution is when it's false. It doesn't make sense. Like when we had that 1 equals 2. Doesn't make sense. Or when the statement is false. 1 does not equal negative 2. Infinite solutions is when it's always true. Like 2 equals 2. That you can't even substitute anything in there for x because x has disappeared. There's no x left anywhere in the equation, but the thing that's left is always true. Well, then that's infinite solutions. The variable has a value of 0 when you have solved and you get x on one side and 0 on the other. That is telling you that 0 is the answer. Can 0 be an answer? Yeah. Like, here's an equation or a question that has 0 as an answer. How many times has Sister Bagley won the lottery? 0 times, right? So, you know, L is the lottery times that I've won or whatever. L equals 0. Okay. Let's just do one more of these. We kind of talked about them a little bit on the front with the vertical angles, but I've given you a little reminder. Supplementary angles have a sum of 180 degrees. Sum means add. So if they were supplementary, you're going to add them up and equal 180. Angles that are complementary add up to 90 degrees, like a right angle. So giving a complement is the right thing to do. Complementary adds up to 90 degrees, which is a right angle. Okay, so hopefully that can help you remember that. Giving a complement is the right thing to do. Okay, here's the problem. Angles A and B are supplementary angles. I'm going to stop right there. I'm going to say that the measure of angle A plus the measure of angle B is 180 degrees. That's the proper way to write that in geometry. I don't really expect you to write it that way yet. We're going to get there later this year. But I'm telling you that two angles are supplementary. That means they add up to be 180 degrees. So if I add their measures together, it will equal 180 degrees. Here I am adding their measures together and equaling 180 degrees. That's what supplementary means. But the measure of angle A is not just written as measure of angle A. We also know that it is 3x minus 4. So instead of the measure of angle A, I'm going to write 3x minus 4. And the measure of angle B, I could write it as 5x minus 8. So instead of the measure of angle B, I'm going to write 5x minus 8. But they still are added up to equal 180 because that's what supplementary means. It means you can add those two expressions together and get 180 degrees. Guess what, kids? That's an equation. You can solve it. Woohoo! Let's do it. Combine like terms. Here's our equal sign. There's nothing to do on both sides yet. We're going to combine like terms first. 3x plus 5x is 8x. So we have this negative 4 plus negative 8 thing going on. That's negative 12. And it's still going to equal 180. Okay, add 12 to both sides. And I get that 8x equals 192. When I divide both sides by 8, x equals 24. Hey, I'm feeling pretty good about that. But, oh, dang it. I'm still not quite finished. What's the value of x? Yeah, that's right there. I got it. 24. But I still have to find the measure of angle A and the measure of angle B. Okay, I knew that A was 3x minus 4. So instead of x, I could put in this 24 here. Oh, did I say 24? 3x minus 4, yeah. 3 times x, which is 24. Substituted that in there. And 3 times 24 is 72. 72 minus 4 is 68. So that's the measure of angle A. Measure of angle A is 68 degrees. Is the measure of angle B going to be also 68 degrees? No, because they're supplementary. They add up to be 180. So you could just subtract from 180 to find the measure of angle B. You could just be like, well, if one of the angles is 68, then 180 minus 68 would give me the other angle, which is 112. But if you wanted to, just because you love algebra and you want to see if you're right, you could plug that 24 in to this expression for B. Go 5 times 24 minus 8, and oh my goodness, you get out 112. How about that? So the two angles are 68 degrees and 112 degrees. So on these angle ones, sometimes they're equal. Sometimes they add up to 180. Sometimes they add up to 90. You have to remember the vocabulary words so you know how to set up the equation. So if you can't remember those, you might need to get those into long-term memory. Make some flashcards. Supplementary is the sum of 180. Complementary is the sum of 90. Vertical, they're equal. Alternate interior, they're equal. Alternate exterior, they're equal. Corresponding, they're equal. Okay? Got to get those learned. Whoo, we're finally there. I'm going to do 4 homework problems. Only 4. I know, because I feel like I've already been talking for almost an hour. Holy cow, this is a long video. So I'm just going to solve these. Don't freak out on the ones with decimals. Just get a calculator. All the rules are exactly the same. So I'm going to start off with number 4. The process is the same. You just have a little bit uglier numbers. Just use a calculator. You'll be fine. Okay, first thing I notice is the need to distribute. So I am just going to recopy this left-hand side. I'm not doing anything over here. Now I'm going to distribute, and I get 9.62R plus 46.102 minus 3.1R. Double check you get the same numbers that I do, because it's easy to mess up with these decimals. Okay, next thing I see is that I have some like terms here. Here's my equal sign. I don't need to add something to both sides of the equal sign yet. I'm going to first combine like terms. So 9.62R minus 3.1R gives me 6.52R. And the 46 is still there. And everything else is still here on the left. You know why I show all this work? For your benefit. How much work should you show me? The same amount. Because when I show this much work for you, you can see what I'm thinking. And when you show this much work for me, I can see what you're thinking in case you mess up somewhere. And then I can be like, oh, they understand the concept, they just made this tiny little mistake. Or, oh my goodness, they have no idea how to solve equations. Yeah, so show your work, always. This much work. These add up to be 0. That was the whole purpose. And on the right-hand side, I'm going to get 12.62R plus 46.102. And over here, I only have 18.338 left over. Plus 0, which is the same thing. So then next, I'm going to subtract the 46.102. Subtract it from over here. And I end up with negative 27.764 equals 12.62R. See, none of the steps are really different. It's not really that hard. It's just, you know, there's more numbers to keep track of. So there's more places to mess up. Process is the same. As long as you have a calculator, it's not going to be that hard. So dividing by itself leaves me with just a 1 or an R, which is what we wanted, right? And then when I type that mess in the calculator, make sure you do the top number first. Negative 27.764 divided by 12.62 is, dun dun dun, negative 2.2. Okay, if you didn't get that, check each step of your work and see why. Okay, here we go, number 5. It's one of those lovely fraction ones. The first thing that you might want to do is to distribute. And you know what? That's okay. That's actually what I'm going to do too. You can distribute. Let's do it. Negative 13 twelfths minus 4/3 n equals, when I multiply negative 1/3 times 3n, I just get negative n. Or negative 1n. You can put the 1 there if you want. And then I have, oh, just kidding, minus 11 twelfths. 1/3 times 11/4 is 11 twelfths. Okay, so now let's get rid of the fractions. What number would I multiply by to make all these fractions become whole numbers? I have a 12, a 3, and a 12. You could multiply everything by 12 and it would work. If you don't see that, then just do 12 and 3, and that's totally fine. I'm going to multiply everything by 12 times 3. 12 times 3, 12 times 3. Yes, even the one that doesn't have a fraction. Everything. You have to multiply every term by that denominator. And remember, you don't have to use the same number twice. There are 2 12s in the denominators, but we just need one. Now, stuff's going to divide. 12 divided by 12 is 1. 3 divided by 3 is 1. Oh, nothing divides there, because, hey, it wasn't a fraction. 12 divided by 12 is 1. So what do we have left? We have 3 times negative 13 minus 12 times 4 times n equals 12 times 3 times negative 1n. I'm putting those in parentheses so that you know you have to multiply and not subtract. Hopefully that's not confusing. And then all I have left here is an 11 times 3. So this becomes negative 39 minus 48n equals negative 36n minus 33. I know there are simpler ways to do this, and you're welcome to do them. If you see it a different way, I am not going to stop you. Do it a different way. But I think this way is just simple for people who have been confused, just to give them kind of like a formula to follow. So negative 48n plus 36n is negative 12n. I've got this negative 39 left. And over here I only have negative 33 left because those added up to be 0. Yay! Now I'm going to add 39 to both sides. Negative 33 plus 39 is 6. So all I have is that negative 12 times something equals 6. Divide both sides by negative 12. What do you get? You get negative 6/12, or 6 divided by negative 12, or negative 1/2. And that's the answer. If you did it a different way, you came up with negative 1/2, awesome, good job. Okay, number 12, it's not really that complicated. I'm going to skip all the middle steps. I'm just going to say that when I finally come up with an answer, it looks like this. Negative 36n equals negative 36n. And if I was trying to combine both of these, I could like add 36n to both sides. But what I am left with there is that 0 equals 0. What does that mean? Does that mean that x equals 0? No, not n either. They all added up to nothing. They were additive inverses. What this means is this is always true, and there are no more x's, or n's, I should say, left in this equation, so your answer is all real numbers. And the shortcut for that is the fancy curly R. Okay. Last one, I'm not going to solve it all the way. I'm going to remind you that not only do you have to solve for x, but you have to find the measures of the angles at the end. It says that angle A and angle B are alternate interior angles. Just as a little refresher, when you talked about parallel lines cut by a transversal, those little marks mean that the lines are parallel. And the transversal is this line that goes across them. You talked about this in 8th grade. Alternate interior angles were those angles. Or yeah, it could have been this other pair, right? What the point is that alternate interior angles are congruent to each other. Their measures are equal. And so if I know one of the measures, it's going to be equal to the other measure. And so I'm just going to help you set up the equation here. Because they are alternate interior angles, I know that the measures that it gives me are going to be equal. If it had said complementary angles, I wouldn't have made them equal. I would have added them together and said that that was 90 degrees. If it had told me that they were supplementary angles, I would have added them together and made them equal 180. So remember, the ones with the angles, you have to decide which kind it is by the vocabulary. Okay, angle A is represented by the expression 2 times 2m plus 1. Yikes, I'm running out of room. Plus 11m. And that's going to equal the other angle, which is 5m plus 2 times 4m plus 7. Okay, you have a big equation to solve there. You should probably distribute. You should probably combine like terms. You should move all the m's onto one side or the other. You should move all the constants onto the other side. The only hint I'm going to give you here is that m ends up being 6. So if you've solved the equation right, if you end up with 6 for m, but then you have to go back and find the measures of the angles also. Okay, that was a super long video, but with good cause, because you have to have this foundation to serve you for the rest of the year. In fact, for the rest of math that you ever do in school, you're going to need these skills. This is never going to go away. So I hope it helped you understand, and I hope this gets into long-term memory and it becomes simple for you. Good luck.